What lies at the center of the Earth? Scientists and explorers have been looking for a clear answer to this question. We know that the Earth is made up of layers: the crust, the mantle, the outer core, and the inner core. What I'm about to reveal might just shake the very foundation of what you know about the Earth. Hello, and welcome to our channel, InWonder. Today, we're going to explore the possibility of the Earth having a core within its core. Get ready to journey to the very heart of our planet and discover the secrets that lie within. So if you're ready to explore the mysteries of the Earth's inner workings, hit that subscribe button and join us on this incredible journey of discovery. Don't forget to hit the notification bell so you never miss an episode. Let's get started. The Earth, our home, is a planet full of mysteries and wonders that scientists are still unraveling. In recent years, new discoveries have shown that there may be something more to the structure of the Earth than we once thought. We know that the Earth has a layered structure with the crust, mantle, outer core, and inner core. But new research suggests that the Earth's interior may have even more layers, like peeling back the layers of an onion or a set of Russian dolls. In fact, the inner core of the Earth may consist of not one but two distinct layers, both made up of solid iron and nickel. Because these layers are so different, we need to look at them separately if we want to fully understand how our planet works. To study the Earth's interior, scientists rely on earthquakes. When light waves hit a change in medium, they are reflected or bent. The same thing happens to seismic waves when they hit internal boundaries within the Earth. However, studying these waves becomes increasingly challenging with depth, as only waves going almost straight through the planet's center are affected. And the noise caused by interactions at boundaries further out makes it difficult to analyze even these. Even though the idea of a central core has been around for more than 20 years, it is still a mystery. In a new study, however, Dr.Thanh-son and Professor Hrvoje Tkali of the Australian National University say they have finally found proof that it exists. By looking at the delays in the arrival times of seismic waves from more than 200 earthquakes of magnitude 6 or higher, some of which had gone through the planet 5 times, they were able to prove that the Earth's core has a core. This breakthrough could provide crucial insights into the formation and evolution of our planet. The deepest part of the Earth's core is still the most mysterious and hard to figure out. But in a recent paper, Dr.Thanh-son and Professor Hrvoje Tkali shed some light on this mysterious layer. According to their research, the deepest core is a solid metallic ball that measures 650 kilometers, 400 miles across. That may sound pretty big, but it's actually smaller than Ceres, a dwarf planet located in the asteroid belt. Nonetheless, it's still the largest solid structure within the Earth. What's truly fascinating is the way that seismic waves pass through this innermost layer. P waves, which travel at different speeds through different materials, pass through the deepest core 4% more slowly on a path angled 50 degrees to the Earth's rotation axis. This means that the iron atoms have arranged themselves into a crystalline structure because the conditions are so harsh. But the inner core isn't just a static structure. It's a time capsule of Earth's evolutionary history. Tkali says that the Earth's deepest core has records of things that happened hundreds of millions to billions of years ago. The authors think that the difference between the innermost core and the rest of the inner core is due to a global event on a scale that has never been seen before. As the liquid outer core solidifies, the inner core is thought to be expanding. However, it's still unclear whether the boundary between the deepest core and the surrounding shell is in flux. These findings raise even more questions about the Earth's core, but they'd also provide a glimpse into the complex and dynamic nature of our planet's interior. Recent breakthroughs in Earth science have been made possible in large part by the huge leaps forward in technology. As the number of seismic sensors around the world grew, Them and Tkali were able to track seismic waves that had gone almost straight through the Earth in amazing detail. Using a big net and putting together information from many different places, they came up with new ways to boost the signal from faraway seismic waves and separate it from nearby noise. The researchers' findings suggest that there is still much to learn about the Earth's core. In particular, they suggest that the line between the deepest part of the core and the shell around it should be studied more in the future. Scientists are always pushing the limits of what we know about the universe. For example, their work on the interior of Mars last year showed that the planet's mantle still has molten material, which went against what was thought to be true. As technology continues to evolve, we can only imagine the incredible discoveries that lie ahead. Who knows what other secrets of our planet and beyond will be uncovered? The possibilities are truly endless, and the only way to find out is to keep exploring and pushing the boundaries of what we know. So let's keep funding scientific research and be open to what we don't know. Who knows what exciting things we might find in the future? What do you think about the latest research on the Earth's deepest core? Are you fascinated by the idea of a solid metallic ball at the heart of our planet that holds clues to Earth's evolutionary history? If so, please let us know in the comment section below. John Tarduno, a geophysicist who was not part of the study, is excited about the new evidence that PM and Tkali have found. Tarduno thinks that this study shows that there is, in fact, an innermost inner core that has a different structure than the outermost inner core. Tarduno also wonders about how this innermost core could have formed. He hypothesizes that a shift in plate tectonics several hundred million years ago may have played a role. Tarduno's theory says that old, thick slabs of oceanic crust at the bottom of the mantle could have changed how heat moved from the core, changing how the inner core formed. Even though Tarduno's theory is based on his own research from last year. So if we want to find habitable exoplanets, we need to know how these fields form and change over time. The work that Tarduno and fam have done on the Earth's inner core is a big step toward figuring out how magnetic fields work on other planets. By looking at the deep interior of our own planet, we can learn about the conditions that are needed for these important shields to form. This information could help us find planets outside of our solar system that might be able to support life and guide our search for extraterrestrial life. The discovery of the Earth's innermost core is a great scientific achievement that tells us more about our planet's history and how it works to keep life going. The study opens up new ways to learn about the deep interior of the Earth and how it is connected to the rest of the solar system. So what do you think? How does this new knowledge about the Earth's inner core change our understanding of the planet? With the help of seismic sensors and other cutting-edge technologies, what other mysteries of the universe might be solved? It's exciting to think about the possibilities, and I can't wait to see what new discoveries lie ahead.